In the fall semester, a group of Midland University ecology students from Professor Manish's class were selected for a groundbreaking research mission, a deep-sea descent in search of undiscovered organisms for their ecological design project. After months of preparation, the team launched aboard a research submersible and began their descent into the silent frozen darkness of the deep ocean. As the sub passed 3,000 meters, the water around them grew almost completely black, except for a faint flicker of movement just beyond the lights. Inside the submersible, the students watched their monitors carefully, and then, something none of them had ever seen before drifted into view. A massive armored creature, glowing blue veins, 8 drifting limbs, and a shell unlike anything in scientific records. The creature released a blinding bioluminescent beam, illuminating the entire abyss for a split second. The team managed to capture only a few seconds of footage before the creature vanished back into the darkness. Within days, the discovery made headlines worldwide. The New York Times front page read, "Midland University students discover new deep-sea species."
Hey everyone, so I hope you guys enjoyed the little introduction video to my organism. So in this part, I will talk a little more in depth about the organism and how I came up with it. My organism is called the Titanogarus abyssaris, or the Leviathan chantanelle, a deep ocean species adapted to extreme pressure, cold temperatures, and complete darkness. I designed it to look very unique, but still follow most or all real ecological and physiological principles we learned in class and that are possible. So let's talk a little bit about the environment. The chantanelle lives between 1,200 and 4,000 meters below sea level. It's really deep in the abyssal zone. At these depths, there is no sunlight, and energy is very limited, and pressure is extremely high. These are very harsh conditions, and they shape most of the adaptations, if not all of the adaptations of the creatures there so they can survive. Morphology and body design. Coming up with this creature, the chantanelle, I thought about making it more unique. So it has interlock hexagonal armor plates, and they are designed to resist pressure. They have bioluminescent veins that help with communication, and 8 muscular tentacles limb for movement and capturing prey. It also has a circular suction jaw that works like a deep sea suction feeder, so it creates a vacuum and swallows its prey real fast, and it doesn't waste that much energy. So speaking about how it eats, the chantanelle is an ambush suction predator. It waits for the prey, and then it extends the tentacles and uses the vacuum like a suction to pull it in. Its slow metabolism and lipid reserves help it survive longer periods of time without food, which is common in the deep sea ecosystem. So what are the defense and sensory adaptation the Leviathan has developed? In total darkness, most organisms need ways to adapt and maneuver and also escape predators. The Leviathan relies on pressure and vibration sensing, similar to fish's lateral line, and the mid-electroreception. Its main defense is bioluminescent flashback pulse, a quick burst of light like you saw in the introduction video that pretty much blinds you completely, and then the creature has time to escape. And then, yeah. So it developed these adaptations to be able to survive in the deep sea. The reproduction and life cycle of the Leviathan. So the Leviathan needs to reproduce, and in order to reproduce, it needs to find another mate. which is extremely hard in the deep sea conditions as everything is very dark and spaced. So it uses bioluminescent signals to look for the mate across distances. The way the females protect the eggs is that they expose it between rocky crevices. I did show a short little video inside the introduction video where you can see like crevices and how like the terrain looks in the bottom of the ocean. So the eggs are able to be laid over there and hopefully protected. And most of the time, for the first few months after the female lays the eggs, the male guards them. Juveniles start to develop a soft body and develop the armor as they grow. This is due to energy saving in early development. The ecological role of the Leviathan. The chanterelle acts as a mid-level apex predator in the abyssal food web, regulates smaller species, and contributes to the ecosystem balance. Its armor plates also create small microhabitats for organisms for a symbiotic connection. So, how do we connect this to humans and how humans can impact creatures in the deep sea? And after doing a lot of research, I understood that our contribution to pollution, to a lot of noise pollution as well, and plastics can really impact the habitat in the deep ocean. We don't know much how creatures live and survive there, but without knowing, we still do these things, and we don't know the consequences. In terms of designing this particular organism, the Titanogaurus abyssaris, it really helped me connect ecological concepts like adaptation, energy budget, and trophics interaction to create a realistic deep sea ocean organism. And it's really like a big circle closed.